Yep, okay, we're good. Excellent, great. So this totally different session this time. We're talking about the Windows Security Configuration Framework, which I affectionately refer to as SecCon, in which all of the marketing folks say, please don't invent yet another acronym that people have to learn. So honestly, you'll kind of see in the documentation, Security Configuration Framework. I call it SecCon conversationally. Whatever you want to call it, what we don't want to do is introduce the 9 billionth Microsoft acronym. So hopefully we can avoid some of that. But I want to kind of start out talking about some of the need, like why do we need to have it? Like what were we trying to accomplish? And then we'll kind of, if anyone who's not familiar with it, we'll figure out what it is. But here's the problem space. We start looking at the policies that we have, and obviously manageability is pretty important. That manageability can kind of go far. And I actually went through and did the math, and this is the actual number of different permutations that you have just for the IE group policy. So not all of group policy, but just the one subset. And I happen to dig into IE specifically because we observed that roughly it's about 30%, so nearly a third of all of the support cases that were opened for Internet Explorer did not reproduce in a default configuration. It was something to do with that customer's configuration. And so we started to try to do the root cause, and this was really the reason is there's a lot of complexity. This is the actual number of different ways that our customers could be configuring the browser at the time. This is obviously a couple of years ago. And to really just put that number into perspective, that's the number of different permutations of group policy. That is the number of atoms in the observable universe, just to give you some sense of just how big that number is. And we sort of look at, what's the challenge? It turns out that even if we were to execute a full set of regression tests in a single nanosecond, that not enough nanoseconds have elapsed since the beginning of time for us to have run all of these different permutations. It simply can't be done. And I have some bad news as well, which is we cannot fully regression test the entire browser in a single nanosecond. So we're really in trouble. So the complexity is both our friend and our enemy. And we think about security, it's actually led to some really interesting what I call unintended consequences. And one example is I was working with a customer, guessing where that customer was located is left as an exercise to the reader. I won't mention their name, but what they had actually done is that they had looked to implement a security lockdown and had imported some recommendations that were being developed by an agency within the United States. So they had an early draft, and they said, you know what, we're super interested in security. We want to make sure that we implement that. And this organization did it, just sort of verbatim copied it, and then noticed that they had a little problem. And the problem was this. The initial recommendation said, hey, from a security lockdown perspective, we looked at the SE debug privilege, and we didn't think anyone needed it. Now, for those of you who aren't sort of deeply familiar with all of the different privileges that exist in the OS. Let me actually pull up, I'll slide this over so you can see it. These are the different privileges that I have. I'm actually going to elevate a command prompt as well. So apologies if that, just making sure that didn't interrupt the display. It looks hopefully not. So let me know if it did. Sometimes it does with some web sharing. mi/priv. And here's the privileges that I have in an elevated token. And this is sort of part of the functionality of UAC is to kind of filter off the particularly dangerous ones while leaving some that are less dangerous. So for example, if you want to, I'll do a brief digression to get a little bit nerdy to talk about what privileges are in case anyone's unfamiliar. But basically a privilege says you have permission to cross the boundary between standard user and admin to do this one thing. Because the boundary is you can kind of loosely define it as a standard user can mess around with all of their own things, an admin can mess around with other people's things. And a privilege is permission to mess around with a subset of other people's things. So for example, the shutdown privilege, if I look at the shutdown privilege, obviously that's going to impact other users of the device because now the device is going to be turned off. But if I don't do that, that means a standard user cannot turn off their computer. And obviously that's a problem. Same thing with undocking. If you undock the computer, it's going to impact other users because the computer now is going to be walking away. But the standard user should be able to undock it. They should be able to change their time zone when they travel. Like all of these are important privileges. They're crossing the boundary. And these are privileges that only an admin is able to do. And one of the privileges is called the SE debug privilege. And the description is not super helpful. Debug programs that actually doesn't really describe what it does. What the SE debug privilege does is it says you will be able to open a process without having to pass an access check. So every process in Windows has an access control list of who's able to get into it. And if you want to debug somebody else's program, you would need to have SE debug because you may not have permission to do that. So it basically gets you past the access check to say, can you open this process in order to debug it? If, however, you're debugging only processes running as you do not need this privilege. And so the folks who are building this says I can't think of a reason why anyone would need to open a process that they don't own. So they removed it from everybody. And here's the unintended consequence of that, right? This is why, having good testing and good coverage is important. It turns out that there are some things that need the SE debug privilege. In fact, it turns out that 100% of all commercially available database software at the time took out the SE debug privilege as part of the install routine. So literally, after they applied this security configuration, nobody could install a new instance of a database. Runtime, not a problem. All of the currently installed database servers were fine, right? Whether they were local or whether they were, on a server, all of those are fine, but they could not install new database servers at all. That is an unintended consequence of a security lockdown. So we've got some challenges of I'd like to know what happens, right? Not only the stuff that it says will happen, but the things that it doesn't say will happen. That turns out to be important. The other thing when it comes to security lockdowns is it's really important to prioritize. And by one example of prioritizing correctly and getting a really sturdy foundation, I had a customer that actually reached out and said, our real concern is we want to make sure that we have the best protection against 0 days in Windows. We're very nervous about that. We hear about that. We want to have those protections. And I said, okay, that's reasonable. So we did some research and kind of talked about their current environment. And it turned out that in their current environment, they had standardized on a single version of Java, which specifically was Java 1.6 update 22. So they standardized down to the update level. Now, at the time, update 22 was far from the most current update level. Like 1.6 already, yes, today it feels very old because it is, but even update 22 at the time was very old. And so we started to do some risk calculation. If we sort of look at putting my priorities in the right order, we actually did, a little bit of research in the dark web to kind of get a sense of what were adversaries charging at the time for vulnerabilities that would target each of these different potential targets, right? I could target the OS, or I could target the Java runtime in order to gain access on the system. How much did a Windows 0 day cost at the time? Turns out it was about $100,000 at the time. So if I wanted to buy a 0 day, I can go on the dark web, no guarantee that it worked, but someone would be willing to sell you something for $100,000 that would presumably work on all shipping versions of Windows. the cost of an exploit for Java 1.6 update 22 was at the time 25 cents. So if I'm building out what do I want to defend against, which one do you think is going to be more likely? It's probably going to be the one that's really inexpensive and trivially easy to exploit. So not only is it unintended consequences, it's prioritization, like all of these things turn out to really matter. We've got a lot of people who are looking to implement a hardening initiative, reduce attack surface, limit the number of functions, right? And kind of go from, hey, we started off in our journey of automation with sort of single function devices, and now all devices can do all of the things. Let's get down to the point where the device can do what it needs, no less and no more, to get this really constrained, easier to protect device. And the philosophy behind what we want to do with security baselines is to follow that approach, to give a path to go through and harden an environment, but in a way that sticks with well-known and proven solutions. So rather than everyone inventing it independently, right? And we see this a lot. One of the metaphors I like to use is if anyone's seen the movie The Jerk, it's a movie from the 1970s, and it's got Steve Martin in it. And there's a scene in which he's like, the new phone books are here, the new phone books are here. And he runs over and pulls it open, and he looks up his own name. He's like, I'm somebody, look. And he's super excited about this. And that honestly is a similar reaction to what I see when we publish the spreadsheet with the new group policies. It's the new group policies are here. The new group policies are here. We call a meeting and we spend the next up to a week cordoned off in a conference room, reading all the policies, determining what's the best answer based upon the English language description of the policy, and then go and try to implement that. And that's really how it goes. And we, quite honestly, think we can do better, right? Is that rather than everyone having to do it, there should be a way for us to share communal knowledge, right? And get to, this well-known and proven solution. So let's kind of take a look at where we are. So what I'll do is I'll kind of drag over, and this is the folder in which I'm storing, all of the policies. And this is what you can download today. This is from the draft version. I haven't updated it in my local copy because I haven't needed to. But what we do is we go through and we look at, hey, let's document the recommendations that we have for a policy. So let me actually drag the Excel spreadsheet over, and rather than it just being blank and a set of descriptions, instead it's like, these are the recommendations that we have. So whether I'm a server, whether I'm a domain controller or a device, right? So if I'm just looking at filtering devices, in this case, I've just filtered towards everything that's not blank. Show me the things that we're explicitly configuring. And these are the recommendations that we have for how to configure it. So rather than everyone having to invent their own, instead we can say, let me go through a well-known and proven configuration. And it turns out that this is the configuration that is used by most of the agencies within the US federal government. We actually partner with various governmental agencies within the United States to build this out, to understand the potential impact. And then we can also benefit from the fact that these have been tested upon millions and millions of devices. So that's great for group policy, folks. In addition, we also have the ability to implement that using Intune. So here's Microsoft Intune, and if I go into device security, I'll actually enter directly into security baselines, and you can see that today we have two of them. We have the security baseline, which is for Windows 10. And what this does is it takes a security baseline as defined for group policy, and it interprets it for MDM. So if I am Intune managing a Windows device exclusively, I can get the same effect. Now, it's tuned for it because if I'm fully cloud managed, there are some of the group policies that are no longer relevant. So we don't reflect those. It's going to reflect those policies that are still relevant in a cloud managed world. We also have one for Microsoft Defender ATP, which allows me, if I'm configuring for Microsoft Defender that I can get all of those features enabled. So we've really built the baselines feature as a platform so we can build more upon it. Incidentally, we already are looking at other things we're building. I know it was just last week that we met with the team that building the next version of Microsoft Edge to establish a security baseline for Microsoft Edge that will be able to reflect as well. So if I drill into it, I can see, all right, here are the baselines. I haven't applied this to any of them, but I can go through and create a new profile, and I can just call this a demo profile. And when I click next, I can see, here's the configuration. Everything is going to be set to the default as recommended by our baseline. Now, you can, of course, configure that, right? And as I'm going through and building and testing the configuration, perhaps I discover that one of these is more impactful. It's going to cause an app-compat impact on something or some kind of environmental impact. So for right now, I can't turn it on. I can, while creating the profile, choose to deviate. But rather than having to start with defaults and set up the baseline, I can start with the baseline and create my exceptions. So I can go through and see, and obviously the browser has a number of configurations, right? All of these are reflected in here, and I can go through and create that configuration as well. So we've established that baseline and made it as easy as possible to implement, whether it be by importing group policy settings or configuring it in Intune to do that way. We'll circle back to secure score a bit later on, but I wanted to talk about, okay, we've got security baselines. Why didn't we stop there? And we sort of took a step back and looked at, hey, what are some of the challenges that we saw people having with those security baselines? The first challenge we saw is that they weren't incremental. It was really an all or nothing thing, right? So you push the entire thing down, and that can oftentimes end up being a 12 to 18-month project, particularly if I have an organization that today isn't using baselines at all, doesn't really have a security hardening initiative at all. Maybe they're coming from a relatively unmanaged environment. If I go from unmanaged, everyone's an admin, UAC's turned off, a lot of other sort of, lack of lockdowns, to fully locked down, I'm probably going to have a pretty significant app-compat impact. So what are the ways by which we can help to take gradual steps? I start with the most incremental ones, right? The easiest ones to implement. We didn't really have that by having a single baseline. The second was that we wanted to make something that was right-sized, because not every device deserves to be treated the same. If I'm doing a security lockdown for BYOD as one example, right, there are some things where I probably shouldn't implement a lockdown. For example, some of the things you'll find in the security baseline are disable Xbox, disable the game experience. And if I'm applying that policy to BYOD and someone has their home computer and they go ahead and say, you know what, I want access to some corporate resources while I'm at home, I'm willing to donate my computer, I'm willing to abide by some rules, but you then block their ability to play games on their own computer, they're probably going to be frustrated, right? And they probably are going to reject that, and they're not going to enroll and have a managed device. Unless their level of access they have merits that, we should be able to have a good balance between security and usability. BYOD being one example. Other example may be, hey, if I have access to, just relatively simple information, nothing too terribly confidential, maybe, I'm, a receptionist, right? So I have access to some information, right? I don't want to be completely wide open, but the risk profile is hopefully drastically different than the risk profile for the domain administrator. I should probably protect those differently. So we didn't really have the concept of, hey, we want to have differential protection for very at-risk users versus, relatively, benign users. What's the answer there? And the third challenge we found is that the baselines are very much binary, right? We only include those settings that have an absolute right answer. And I'll give an example of one control we have where there is no right answer. And that control is Windows Defender Application Guard. And if you were around earlier when we were talking about Microsoft Edge, that is a solution that allows us to put Edge into a Hyper-V container to protect it. But defining that requires environmental input. I need to define what's inside the boundary, what's outside the boundary. I can't just turn it on. I have to enable it and say what goes inside, what goes outside. Otherwise, it doesn't do anything. So we can't define that in a baseline because the baseline is designed to be just imported. So we wanted to be able to expand past that so that we could have non-binary answers that we can gradually implement as part of a security hardening workflow. So those are the challenges we sought to implement. And so we kind of divided off the solution to say, we want to start with hardware because there are a lot of features that take place in the OS that are dependent upon having hardware enforcement. You know, AppGuard is one example. AppGuard leverages virtualization-based security. I need to make sure that my hardware supports a rich virtualization experience. And you know, some very budget hardware or older hardware doesn't do that. So what's the standard I want to implement to reach a certain level of security? I want to, of course, grab the policies, and it was very important for us that the policies we implement inside of the framework that we're building aligned very closely with what we built for the security baselines. We didn't want to have two different opinions on what was right. We wanted to take what was there and look to, how could we extend that in useful ways. We wanted to extend those policies with those controls that required configuration so we can start to address that whole new audience. And we also wanted to look specifically at the behaviors of the users because it's never just technology. It's always people, process, and technology. And there's things I have to do differently if I want to end up having a secure configuration. I want to kind of poke at the hardware specifically and kind of get into some of the details of what we were trying to do. We started to have a conversation, and there's actually some defined levels that we have for modern device security that we talk about. But this messaging was not always reaching the IT pros who were looking to enable some features. And it was starting to become a real problem, right? When we talked to IT pros, we did find that, hey, more than half of enterprises really do prioritize device security. We had, more than half reporting at least one incident of malware infected firmware. We had only 8% of our customers said that they really felt prepared for firmware related exploits. And there's a lot of UFI rootkits that are now available in the wild. So it really is a problem that's worth protecting against. So we started looking at, hey, how can we define different device security levels, right? And it kind of starts with, all right, let's look at, let's at least have a TPM to kind of get to level 1, kind of table stakes that we can actually have, drivers and firmware that we can update. When we start getting into the second level, then it's like, hey, to have good enough support for virtualization that we can start to enable those features by default, that we can enable features like Windows Hello, that we can have kernel DMA protection, all the way up to level 3, which gets specific platform requirements, modern standby, which is a requirement for system guard, and all the various protections that really enable a high security experience. So to kind of simplify rather than a big stack, it's like moving from VBS capable to VBS protected to a full system guard environment around the devices. So we looked at devices and controls, and what we said is, it's probably not one level. It's also probably not a different level for every organization in the world. Right now, we're thinking, maybe it's 5, right? And again, we're super eager for input from customers to say, have we actually hit something that goes close to what you need so that there's minimal configuration, minimal exceptions required. And it kind of goes through, 5 different levels. And I'll be honest, I kind of, was, if you've seen the movie War Games, another 1980s movie, so I'm kind of dating myself. but in war games, it kind of goes to the DEFCON construct, and that's actually still a thing, but folks who are not in the military, that's sort of the only place I had heard of it. That's kind of what's modeled on, so you can kind of see the different levels. But the idea is this, that you can kind of pick the right size environment, whether you're going to make your way through it in a stair-step fashion, or whether you're going to sort of settle on one for a while to move through, hey, here's the basic security, right? Table stakes, this is where I need to go. Enhanced if I'm adding more risk. High security if I really need to defend. So this is the level, for example, that we would see the three-letter agencies within the US federal government targeting. All the way up to, hey, specialized workstation. We see this for tasks like developer workstations, and we'll talk about that in a bit, or an administrator workstation. So let's take a look at what that is today. And I also want to kind of talk about where it's going or where we're thinking of taking it. If I go to aka.ms/seccon framework, it'll give you a shortcut to get here. Otherwise, you can just do a search for it. It's sitting inside of the security baselines and security guidance. And what we've done is we've separated out into, hey, here's an overview of what we're trying to accomplish and the deployment methodologies to get there. And then it runs through the different levels. Now, today, it's not the world's most usable to immediately implement because it is HTML tables. So for the policies that are here, right? So if I look at the hardware recommendations, the policies all come from the security baseline. So this is a proper subset of level 3. If I get to level 3, these policies, all 3 of them stacked on top of one another, would exactly equal the security baselines. So what we've done is we've partitioned them off and said these are either going to be more apt compat risk or more impact to usability as I move up the framework, or it's not going to give me the same bang for the buck. And I'll give you one example. Let me quickly find that. Yeah, autocomplete is one example, like basically a password safe. So we have a password manager that we have both for Microsoft Edge and for Internet Explorer. And that's actually a bit of a security gray. There's no absolute right answer. So if I look at, what's a password manager going to do? On the plus side, a password manager is going to, when we actually measure it, lead to more unique passwords used on sites because now the user does not have to rely on their memory to get access to that password, and more complex passwords, right? It's not guaranteed to do that. You could still use a password manager and use a terrible password on every single website, but on average, it leads to better outcomes, right? And one of the things we're actually looking at is, can we pair a password manager with a password generator? So that we actually drive more unique passwords, more complex passwords, without having to rely on user memory to achieve that, right? So enabling it leads to better security outcomes. But if I have it enabled, now I have one place for an adversary to go and fetch all of your passwords, right? So there's a potential downside to that as well. So if I'm thinking about security hardening, it's like, yeah, this is kind of a mixed bag. I'll get some security benefit, I'll get some security cost. And if I'm starting from nothing, would I start with a password manager, or would I do something like enable credential guard, right? And if I'm looking at overall security, it's like, am I going to have better security outcomes by enabling CredGuard or disabling my password manager? On average, it's probably going to be a better outcome to enable CredGuard earlier. So this leveling system allows us to prioritize, right? Before you go through the pain of turning off a password manager, right, or configure it in a particular way, do the low-hanging fruit. This is relatively trivial, right? If I don't have anything blocking me, such as NTLM v1, that's a potential compatibility impact. It's less and less common these days. So without any obstacles, it's trivially easy to implement and drives great security benefits straight away. This is something where I'd want to invest my time. So the intent here is, let's put out the hardware recommended policies, controls, and behaviors, right? And if we look here, we're like, hey, you know what? Behaviorally, we should be deploying, right? And we ideally want to get our quality updates or Patch Tuesday security updates, however they're called. We it's got a couple of different names these days. Let's get those put out within 7 days, right? Aspirationally, let's move away from it takes me a quarter to deploy security updates. It takes me a month to, ideally, I'd like to get that to within a week. And as we move up, the chain, right, we started looking at things like, hey, let's remove admin rights, which is in itself an entire project for a lot of customers. Or even at enhanced, right, behaviorally, it's, hey, let's look at, how to, manage updates, right? So whether or not you are using the Microsoft Defender antivirus, you want to make sure it's protected, because the way that we have it configured, as soon as a third-party antivirus is installed, we will switch ourselves off, unless you're using Windows Defender ATP, in which case we just switch ourselves into passive modes. Either way, we're no longer providing that real-time protection. But if the other one ever gets uninstalled or doesn't start for some reason, it'll click on. We want to make sure that it's updated, right? So that we kind of never have that period of time when I live with no protection updates. So having it so that we fail over to pull updates from Microsoft directly, so it gets those updates, ends up being important. I want to continue to push on get my security updates deployed as quickly as possible. Can I start to reduce that? As well as, hey, is there a way I can start to take my help desk? And we've actually seen that in a number of the recent compromises. So if you follow the security news, there's been quite a lot of it, even in the mainstream news, where we see a lot of state and local governments being impacted by ransomware. And one of the vectors that we've seen in a number of those is they get on a single device and they find the credentials for the help desk. And today, the single most common way that we still see for how do I allow the help desk to service an endpoint is when you join the help desk, you end up in the /helpdesk group in the domain that gives you local admin rights on everything else in the domain, sometimes even servers. And now that I have admin everywhere, if I get onto any device that the help desk has connected to, I get admin rights to every device in the organization. That has actually been used in a number of things. So starting to transition to a means to do that in a one-to-one manner starts to dramatically reduce risk. So hardware policies, controls, behaviors. What we have today is this giant HTML table. And what we're really looking for is early feedback. And that's why we released it this way when it really is, again, not super easy to use. I get it, right? Because who wants to read through a table and implement that? But to say, do we have the right number of levels? And are they the right controls? And is there anything that people have, in their experience, found to be harder or easier? So we can say, hey, we're enforcing the right thing. Because before we go and make it easy to automate, we want to make sure that we're automating the right stuff. So really, really eager for feedback on whether we have the right controls enabled, because the next steps will be to find it, make it easy to implement that, across a large number of devices, whether it be by having that, be a group policy set that you can import and quickly deploy, or having that explicit support inside of Intune. So directionally, that's kind of where we're heading, continuing to listen for feedback on, do we have the right levels, do we have the right controls? Now, the top two, and actually I didn't point this out, so let me quickly go there. 4 and 5 are, hey, we're working on it. So let's talk about what they are, and then what we, where we are today in terms of the, hey, we're working on it levels. Is that we want to make sure we have the right controls for developers and administrators, because we kind of talked about help desk, but it's this general problem space of, hey, we're going to target various places in the supply chain. And if you're with an organization that is actually creating software, this is becoming a larger and larger risk, because when we look at some of the attacks that have happened, here's a really famous one, not Pecha, where we saw, hey, they were dropping and executing files on the device, and those files were doing credential theft, and they were using Mimikatz, because of course everybody uses Mimikatz. And they were propagating using SMB copy. They were using Eternal Blue. They were using a number of different mechanisms to go across and above and beyond cred theft. And then they would encrypt the MFT and then it'd own the device. But what we want to remember is that actually started a little bit earlier, right? The adversaries first compromised the developer's device at an organization called MEDOC, which makes accounting software that's used throughout most of the Ukraine. In fact, they have over 90% market share, or they did at the time. Actually, I have not checked their market share numbers lately, but that's how they became so prevalent within the Ukraine and within people who did business with the Ukraine. They hit a dev and they put some of their code into this software, and they released a backdoor update to their customers. So they basically relied on people taking an update to compromise it, but they didn't protect this software supply chain. And this was something that we've seen played out a number of times. We saw it in CCleaner, where they compromised the developer of CCleaner. They injected the Floxif malware. They digitally signed it with that developer certificate, and they distributed the software, which then downloaded Trojan, the Trojan software, and then the customer would lose. And as far back as 2017, it was very prevalent, and it's only been increasing since then. We sort of look at kind of the space now in terms of the supply chain. The Equifax breach was root caused to some software. It was the Struts framework that they had been leveraging, part of their software supply chain. That software has been downloaded 21 million times in the past year, already known to be vulnerable, already led to a huge compromise. The supply chain is actively under attack, and so we continue to look for means to protect it. So one of the architectures that I talk about, I kind of call it the tree of code, is to make sure that we're actually protecting the flow of software until it gets signed. So from an idealized perspective, right, my dev box is going to be very tightly hardened. Now, developers, by and large, really don't want to have controls applied to them. They want to be admin. They want to install. So they have software that updates daily, that the update itself runs as the user, and that's really tough to do. So one really key separation is to get their dev box and their test infrastructure separated by a VM boundary. So getting to the point where I'm actually doing that regular modification in a test VM, right? So from a product perspective, we're looking at how do we continue to make that experience better and better, whether it be a local VM, whether it be a remote VM that I'm connecting to, but how do I start to really constrain the dev box so that I dramatically limit its surface area without making my developers unproductive, right? And at least as of right now, I'm thinking getting more and more into the test VM is a way to help do that. Then chasing that path to say, hey, my source control server, my build server, oftentimes are the same, sometimes they're separate. Nonetheless, making sure that I have the same hardening applied there, that I'm accessing them with PAWs or privileged access workstations, that I'm leveraging PKI to get it digitally signed so that I can, have this, attestation that this software has not been modified since it was built on this server, and I've protected the path of that code along the way. And then afterwards, I can just go back and verify that. If I have check-in rights, I ought to be locked down. If I'm just consuming it, then that is okay to have looser constructs so I can make sure I keep people productive. So that construct, now we've not built it, and I wanted to kind of explain some of the details behind what's going on here, because SecCon, or the security configuration framework as it exists today, is written in the language of group policy. And we have the work we've done to start to protect these additional scenarios, so whether it be developers, whether it be administrators, the work we've done already is written in the language of MDM. It's written in the language of Intune. And our recommendation is, hey, we think one of the better ways to protect a device, right, is to have separate cloud infrastructure to go through and implement those protections rather than, putting them into the same on-premise controlled environment. And that's a lot of the work that we've been doing, is to make sure that we are able to respond to the dual perimeters that we have to deal with today. Because today's modern perimeter is identity, right? Identity is, the new perimeter that we have. But there's still a lot of legacy software, legacy services, legacy servers that depend upon the classic perimeter network controls that will leverage things like trusted subsystem as a security control, where we have to sort of actually defend those boundaries. We end up kind of doing both along the way. So how do we start to develop modern constructs? We've got a different set of threats, particularly as we do more of a pivot to the cloud, that we have a lot more potential risk, a lot more potential usage. For example, when you get into cloud scale, crypto miners suddenly become quite lucrative, particularly if it's somebody else is paying for the CPU. So we start to see a difference in terms of what happens when we get into those dev workstations. So we've been evolving to say, you know what, let's take the PAW guidance, which is the guidance that we published a while back, that says, hey, here's how to develop a hardened workstation designed for administering devices, and evolve that to leverage these new cloud-based constructs. So I wanted to point to that content, so aka.ms/secured workstation. We also have the scripts that implement that, so you can directly configure an Intune instance. So secured workstation Git, it's all hosted on GitHub. So you can create a PAW-like device that's managed and secured by the cloud. And so, there's right now we're still working on kind of uniting it. So if we look at how the model comes together, it's leveraging the same buildup that we have for the security configuration framework. So we start at low, enhanced, high, specialized, and secure, or PAW, right? So we call that the administrative scenario. It's all the same things. This is in the language of cloud, right? So the kind of the work going on behind the scenes is to extend that and make sure that we get the same protections if we're managing that via on-prem, because that's still important for a number of key scenarios. It's still important when I have air-gapped networks. So we see that in government organizations. We see that sometimes as well in financial services, because there's still a number of legacy solutions that depend upon trusted subsystem. We see that as well in manufacturing, where sometimes they'll say, we have a lot of old stuff here, let's network isolate it. So it's a bit difficult to put all the cloud controls at once, right? I've got to do a lot of work to make sure I can figure that up there. For right now, I want to make sure I manage that. So the work going on behind the scenes is to look at, let's get these last two scenarios, right? The specialized, or developer is the key scenario. I think that we should be looking at first into, hey, what do we do with a privileged access workstation? I'm administering, a server or a service, particularly if it is a strategic one. So whether it's identity or my security infrastructure, or even my systems management. If I gain access to SCCM or Intune for the entire environment, I can deploy arbitrary software to everybody on there. Obviously, that's something that I really want to protect. So all of those go through this mechanism. So if we sort of look at, implementation-wise, one of the goals we had was to allow the use of autopilot. So we can just sort of ship devices and go through and apply this particular set of policies and go through and authenticate into a service, right? And then gradually ratchet up the security configuration that I have as I move up in terms of risk profile. So to kind of sum up, where we are and where we're trying to head, what we find is, hey, we don't think there's one right-sized solution for all security hardening. We think that there's probably several. We're curious to understand if we've gotten all the right scenarios. So continued feedback. Again, I mentioned this in my last session. I'll mention again. On Twitter, I'm at appcompatguy. My email is appcompatguy@microsoft.com. I'd love to hear your feedback on, hey, here are some additional scenarios that I don't think are quite covered. Let's have that conversation. Our belief is that hardened workstations are better with the cloud, but we also believe that not everyone can get there for every scenario, so we need to accommodate both. We want to hear your feedback, and we want to know what we've missed, and a quick overview of here's where to go and find all of the documentation that we have. And again, this is something we're pretty early on, so I'm kind of presenting like, hey, we're just starting on this journey. We've got the security baselines. We are continuing to invest in them. we think we need to add more of them, we're listening, and we're super eager to make sure that we can make it as easy as possible for everyone to stick with well-known and proven solutions, to go through and get everything configured, and to lock it down without taking on quite as much risk. So with that, I will open up if there's any questions that didn't come through in real time. No one interrupted me, but that could have been because I didn't feel like interrupting. Amy, are there any questions from attendees?
There are not any questions. There was a request for your slides. If you're able to share those, you want to email them, put them on OneDrive, or just decline, that's fine too. That's the only thing that came in.
Cool. Yeah, no, I'm happy to clean up and share at least this one. I have to check with the other one to see if we're sharing it broadly. I always, if something's made by, in partnership with some of the engineering folks in Windows, I usually check with the PR folks just to make sure they're like, yeah, it's okay to present that, but not share it. Windows is a weird place like that. So I'll find out, but this one's easy. Yeah, this one I can definitely share.
Fair enough. Okay. Well, if there are no more questions, trying to stall to give people a chance to type questions, but it doesn't look like there are any more questions. So Chris, thank you so much for your time. Want to give a big thanks to all the attendees for joining as well, and we will definitely be doing more of this in the future. So thanks everybody, and I hope you guys all have a great day.
Cool. Thanks all.
Okay.